Hi everyone. Today I'm gonna go through the second question of November 2017 final paper. This is the first question of the booklet I gave you the other day. So let us go through it. The second question says, study the structural formula below, and let us look at the structural formula. As you can see, we have carbon and hydrogen atoms all around, but here we have an unusual section in the molecule, which is made of a carbon atom bonded to an oxygen atom with a double bond, and there is a single bonded oxygen on the other side. Such groups are belong to esters and the carboxylic acid. To be a carboxylic acid, there must be a hydrogen atom bonded to this oxygen atom. But as there is no hydrogen atom, rather a carbon atom attached to this oxygen atom with a single bond, we call this an ester rather than a carboxylic acid. So for this compound, write down the homologous series to which it belongs. It belongs to esters homologous series. By the way, what is a homologous series? You need to always remember that definition. A homologous series is a group of organic compounds which can be represented by the same general formula, or they differ from each other by a CH2 group. So you need to remember always this definition, homologous series. The next one, what is the IUPAC name of this compound? To name this compound, firstly, we need to divide this compound into two parts. And where we divide from where the oxygen atom single bonded to the side group, not to the functional group carbon atom, but to the other carbon atoms. This part is taken as a side chain. We treat it like a substituent. And the rest will form the parent group, the main group. To write the IUPAC name of this compound, we take first the name of side chain, which is made of, as you see, two carbon atoms. So we call it an ethyl group. We write here ethyl, and the rest has 1, 2, 3, 4 carbon atom. An alkane with 4 carbon atom is called butane. But what we do here, instead of writing butane, we write butane and we remove this E letter. We don't write here E letter. Instead of E letter, we add here O8 suffix. Remember, the suffix that we use for esters is the O8. We basically remove the E letter of butane and add O8 suffix. That is the IUPAC name of this compound, ethyl butanoate. 2.1.3 IUPAC name of organic acid used in its preparation. Actually, we haven't gone through this section yet, but let me briefly explain what it is. An ester molecule is obtained when a carboxylic acid react with an alcohol. When an alcohol and carboxylic acid react, they form an ester. We call this reaction, as we obtain an ester molecule, we call this reaction esterification. Sorry. In this process, the carboxylic acid acts like a simple acid molecule. Sorry. Carboxylic acid acts like an acid. Alcohols behave like a base. That means the alcohol gives away OH group while carboxylic acid gives away the H. That indicates that this main group, this part, comes from carboxylic acid, and the side chain comes from alcohol. So, to form this ester, what do we need? We need an organic acid, the carboxylic acid. What kind of carboxylic acid we need? We need a carboxylic acid with 1, 2, 3, 4 carbon atom. A carboxylic acid with 4 carbon atom is called butanoic acid. That's it. We will explain more. I'm gonna go through this in the reaction sections, which is this section 3, but this is enough, I guess, for now. Structural formula of its straight chain functional isomer. Alright, now let us remember what is an isomer and what is a functional isomer. We have structural isomers in organic chemistry. Those isomers are the organic compounds with same molecular formula, but they have different structures. So the organic compounds with same molecular formula, but different structures are called structural isomer. We have 3 types of functional isomers. The first one is the chain isomer, second one is positional isomer, and the third one is functional isomer. In a chain isomer, the difference is the structure of chain, and positional isomer, we have a different location of the functional group or side chain, and in functional isomer, we have a different type of functional group, a different type of functional group. And we need to remember that esters are functional isomers of carboxylic acids, and aldehydes are functional isomers of the ketones. Here my compound is an ester, and we are looking for its functional isomer. The functional isomer of an ester, as we just mentioned, is a carboxylic acid. So we need to rearrange this molecule to make a carboxylic acid. To make it a carboxylic acid, let us start from the functional group. Functional group should be a carboxyl group to be a carboxylic acid. So here I wrote the functional group. And we are looking for structural formula. So here it can be better if we write this oxygen atom separate. Okay, that is always the safest way. OH can be accepted, but better to write O-H. That is the safest way. And then let us count how many carbons we have in the ester. 1, 2, 3, 4, 5, 6. So here I need to write in total 6 carbon. This is my first, that is second, and the third, fourth, 5, and this is 6th. And the rest is simple. Just add the hydrogen atoms. Here this one needs 2, 2, 2, 2, but that one needs 3 hydrogen atoms. Here I need to remind you one thing. If you leave like that, sometimes we get lazy or we just forget to add the hydrogen. We just put the dashes and leave it like that. You will lose marks. So never leave like that. Add the hydrogen atoms. Yes, it's time consuming, but that's the way. So please do not forget to add these hydrogen atoms, even though it is so many. Alright. That is the structural formula of straight chain functional isomer of this ester molecule. And the name of this, it's not asked, but let me just name it. name of this compound is, as it has 6 carbons, is hexanoic acid. But you are not required to write. Actually, you mustn't write hexanoic acid, only write the structural formula. So that is question 2.1.4. The next one, write down the structural formula of 4-methyl pentan 2-on. Here we have an IUPAC name given. We are required to write structural formula. It is important to write whatever asked in the question. If it says structural formula, we must write structural. If it is condensed structural, then we have to give the condensed structural formula. Do not change it, please. So, what I have an IUPAC name which ends with on. That means that this is a ketone. This compound belongs to ketone family. Ketone homologous series. I have the functional group on the second carbon. The longest chain has pentan, which means 5 carbon atom. I have a methyl group of substituent, and it's on the 4th carbon. So it is that simple. So let us start with the longest chain. How many carbon we have? 5. Then I write here 5 carbon, and I join them with single bond, 3, 4, and 5 carbon atoms. That is question 2.2. Let us write the functional group. For a pentanon, or pentan 2-on, for a ketone, the functional group is carbonyl group. Carbonyl is the carbon atom attached to an oxygen with a double bond, and it must be on the 2nd carbon. So here I write a carbonyl group, carbon double bonded oxygen. And then what is left? The substituent, which is methyl. Where is the methyl? On the 4th carbon. I start from here, 1, 2, 3, 4. So here I have a methyl group, CH3 group. But as we are required to write structural formula, we write hydrogen separately. The rest, just add hydrogen atoms around the carbon atom to make their octets complete, which means to make each and every carbon have 4 bonds. This one has 4 bonds now. That carbon has 1, 2 bonds already, so I need to add 1, 2 more. This carbon has 1, 2, 3, so add only 1 more hydrogen, and this one has 1 only, so I need to add 3 more hydrogens so that it's gonna be complete. And that is 4-methyl. Let me show. This is 4-methyl and pentan 2-on. 4-methyl pentan 2-on. That is the structural formula of it. And the next question, consider the structural formula below. Let us look at the structural formula again. This molecule is all made up of carbon and hydrogen atom. There is only a small unusual section, which is a triple bond between carbon atom. That easily makes it an alkyne. So this is an alkyne molecule. Presence of triple bond makes it an alkyne. General formula of homologous series to which it belongs. Alkynes have a general formula CnH2n-2. And lastly, what is the IUPAC name? To write the IUPAC name, we need to choose the longest chain. Here it's important to choose the right chain. I can see that the right chain is this straight chain. So this is my longest carbon chain. And then I have substituents. Here I have a group of 2 carbon atoms. That makes it an ethyl. Here I have 1 carbon substituent, and here I have another one carbon substituent. That is also a methyl. So I have two methyl groups, sorry, and one ethyl group. What we need to do, guys, we need to number the carbon atoms in the longest chain after choosing the longest chain. We can start from left or right. We need to decide. As you see, the functional group is closer to the right side, so I must start from the right side. This is the first carbon, that is second carbon, third, fourth, fifth, sixth, and that's my seventh carbon. I have methyl groups and ethyl. Alphabetical order tells me that I must start with the ethyl. So we will say 5 ethyl, and then I have methyl groups. One is on the second carbon, the other one is on the sixth. Dash 2, 6 dimethyl. As I have two methyl groups, I need to use di prefix. And the longest chain has how many carbons? 7. That makes it an heptane. Normally it is an heptane. But this is not an alkane. We remove this ane suffix. We need to add in. But sorry, not in, ine. It's an alkyne. We need to add ine. Where is the triple bond? It is on the third carbon. So hept 3 ine. That is the IUPAC name of this organic compound. So that is all for this November 2017 question, guys. Thank you for listening. I'll see you in the next question. Bye-bye.